Okay. Share. Okay. So over here you can see Google. Let's go to Google. Resistor image. So you can see various type of resistor, and this is the type of resistor with the color code and the tolerance here. Okay. So resistor color code. Then you can see different color code for resistor. Okay, start from here. All right. This one is the color code for resistor. Okay. Normally what we're going to use will be 270 ohm. Okay. So we're going to use the resistor we're going to use is basically 270 ohm. Okay, 270 ohms. Okay, so this is the color code. You just remember this. If you forget the value, just refer to this table and you can know the value. Then you have two. One is a serial and parallel. If it's serial connection, you have two resistors, so the total resistance value will be R1 plus R2. Okay, the R1 is here, R2 is here. If it's in parallel, the total resistance value will be R1 times R2 divided by R1 plus R2. Okay, so this one if you connect in parallel. Serial and parallel, what will be the difference? What will be the difference between serial and parallel? Serial and parallel. Okay, what will be the difference? Okay. So let me show it to you. Yeah. Where they insert the diagram. Okay. All right. Before here, let me see. You have a serial and parallel. Okay. Let me share the PowerPoint stuff. Okay. If it's a serial, so it's on the. We refer to external wiring. If it's a serial, you have two lamp, one switch, only one wiring. Okay, just one loop. So you save costs. If you have parallel, probably you have two lamps and probably you have two switch. Right? So you actually have two wiring. Right? So this extra cost is double. Right? Double the cost. Okay? Yeah, you see that? The cost is double. So that's the main difference between serial and parallel as far as the wiring is concerned, or external wiring is concerned. Okay, so let's stop sharing, and then let's share. Oh, faster. PDF file. Okay, we're going to switch here and there. Okay, the last thing is a breadboard. The breadboard, this is the wiring from here to here. There's one copper track, so you can connect. So on this breadboard, there's a hole. This hole, you're going to plug in the wire into the hole. All right. So you want to make a connection, you can plug in the blue color here and connect to here. is the same wire, okay? It's a connecting wire. So this is a breadboard. So you want to put a chip, you have to put it here, okay? So this is how the wires are interconnected internally. So you can see over here, there's one copper track, one copper track, one copper track. All these 5 pins is one copper track. Okay, so this is a breadboard. This is how it looks like in the lab. Okay. Then there's also LED. In the LED, you have the legs. The longer leg is the positive LED. So because the LED you can burn easily. So what you need to do is that you need to connect a resistor. You need to connect the power supply to a resistor. Then only you connect to the LED. Then only you connect it to the ground. This is how you're supposed to connect the LED. The longer side is the positive side. Okay, the longer leg is the positive leg of the LED. Okay, so let's now I stop the sharing and we go to the website. We go to the web. And okay. Okay, can you see the screen? Can you see the resistor screen? Okay, so we took a breadboard. So this is how it looks like. Okay, let's say you want to connect. So you connect to the positive to a resistor. Then you connect to the LED. And this is the ground. Negative, positive. All right, you can see that. This is how it looks like for LED connection. Okay. Okay, I think this is a wrong way of doing it. Okay, because it's connect to LED first before connect to resistor. This is how you connect you put the chip inside the breadboard. Okay, this is how you put the chip inside the breadboard. Okay, you put it here, then you can connect all the wires here, all the wires from here, here, and here. Okay, let's look at the LED. Oops, hi. Let's look at LED. You can see connect to a resistor to the LED, the longer leg of the LED. Let's look at LED. Can see this is positive, this is negative. This is how LED looks like. Okay, right? Clear?
So before you continue,
Uh-huh.
what about that 4-pin one? How does that work?
Which one? The 4-pin?
It's on the same page.
This page?
Yes. Yeah, you pass it. It's also by Cytron technology.
Oh, this one, 4-pin one. This one, is it?
Yep.
RGB, is it? Red, green, blue, I think, or something like that. This one, I'm not sure. We are not using this one. All right.
Okay, thanks.
I'm not sure. All right. Color red, green, blue, 4 common, 4 pins. Have to look at the data sheet lah. I download the data sheet. I click on there. Oh, download the data sheet. Data sheet is in Chinese. Oops, the data sheet is in Chinese. Okay, I cannot read. You have to read through the data sheet lah. Okay, then you need to know which one to connect to lah. I think it gives you different color lah. Okay, I'm not sure. Okay, thank you.
Okay, thanks.
All right, but we will not be using it lah. Okay, and so far in my whole life I did not use this. I only use 2-pin one. 4-pin one I didn't use lah. All right. Okay, then what else? Hey, you asked me some question that I forgot about it. Okay. All right. Where's the? Okay. LED. Then you look at breadboard. breadboard. This is how it connects. So this is how you put in the chip. You can see this is how people put in the chip there. Okay, plug in the chip. Like this. This is how. Oops. You can see where is it? This is how people plug in the chip. All right. Plug in the wire, ground, VCC, LED. But it's not that neat lah. When you do the time, it will not be that neat lah. Okay. All right. Clear. Any questions so far? So far, any question? So you can see this pin 7 is ground. So it connected to the ground from here to here. You can see. Then the VCC is here. This is VCC connected to this pin pin 1. This pin 14 is ground. Okay, VCC is here. You can see red color. Red is VCC, black is ground. Okay. But this is the color code standard lah. Okay. But then when you do the lab that time, you might not follow lah. Just see got any wire, you just use it. All right. Breadboard connecting wire. Let's see connection wire. This is the wire you use. Yeah. These are the wire you use. Okay. Some of the wire you use to connect the breadboard. Okay. What else you want to ask? This is how it looks like in the lab. It looks as messy as this. Okay. But this is a advanced microcontroller class, I think. So many chips, so big one, the size. Okay, any question you want to ask before we move on to the lecture part? Anything you want to ask? No,
Yes, sir. Just now you brought up something called the VCC wire. What is that?
VCC means it's a positive. Ground means there's a negative. Right? Sorry. Right? VCC means plus 5 volt. Ground means 0 volt. Okay. What else? Okay, no more. So stop sharing. Let's go to present the PowerPoint slide. Okay, serial parallel. So then we look at what you call, can you see the PowerPoint slide? Yes or no? Can you see the PowerPoint slide? So you have various gate and or not. First thing you must understand the English language. If you don't understand the word, that means you have to refer to a dictionary. Okay. So not, what's the meaning of not? What's the meaning of and, or, and XOR? All this meaning, all right, you must know it by your heart in the English dictionary. If you don't know the meaning of the words, then you are just memory. You're just memorizing, okay? You must know the meaning, all right? The exact meaning will come from a dictionary, okay? If let's say you don't know any, let's say next time you don't know any terms you don't understand, you just refer to dictionary. Refer to dictionary, okay? Forget about all the technicality of that. Then after that, you refer back to the technical terms, then you can understand better, okay? It has to do with the language, nothing to do with the technical, okay? So, okay, not white means what? it means it's not white. What if it's black? Black is not white. Blue, is it white or not? Blue is also not white. Okay, not Malaysian. It can be African. It can be Asian. It can be Indonesian. Okay, and so on. Opposite of something. If it's not true, it is false. If it's not false, it is true. If it's not 1, it will be 0. If not 0, it will be 1. So this normally, when we talk about digital system, we normally only talk about zebra, black or white. It's true or false. Okay, no in between. Okay, just remember that we are not talking about fuzzy logic or what. We're talking about zebra. You only see 2 colors, black and white. Okay, nothing else. Okay, so the next term you have to understand, language is N. So I want handsome and rich. Okay, handsome and rich. If handsome and poor, one or not? Acceptable. Acceptable or not? Handsome and poor? No, no. If ugly and rich, acceptable. No, nehi, nehi, nehi. Okay, ugly and poor, 不要. Okay, both must be there. It must be rich and handsome. Okay, both quality must be there, rich and handsome. 聽到未？聽到未 ？Rich and handsome. Dengar tak? Dengar tak? Mau handsome dan kaya. Okay, you heard it. Okay, rich and handsome. Okay, the word and is inclusive. Okay, that's the meaning of and. Okay, let's say as your age plus, you begin to compromise. So from N, you can become okay lah. From N, we become O already. Okay, O already. Okay, so I want handsome or rich. If it's ugly and poor, okay, you not accept. But it's handsome and poor, you accept. Okay, if it's ugly and rich, you also accept. Handsome and rich, also you. Okay. Right. Okay, clear? So now you understand the language between N and O. Okay, N and O. Don't get mixed up N and O. Okay. So then you have a truth table. The truth table is a verdict, it's a judgment book. Okay, it's a judgment book. So you explore all the possible scenario. So you have only 4 states, isn't it? 4 possible combination. Correct? Either is ugly and poor, ugly and rich, handsome and poor, handsome and rich. So if A and B, this one will be the final result. If A or B, this one will be 0, 1, 1, 1. If either one of these is 1, you will accept it. Okay? All right. So this is the truth table. Okay. The number of states is 2 to the power of number of variables. Okay. Okay. So if you have 2 variables, so it will be 4 states. Okay. Then next one is if you have 2 variables, you have 4 states. If you have 10 variables, you have 1,024 states. If you have 20 variables, you have close to more than 1 million states. All right. So it is good when the number of variables is small, you can use truth table. All right. If the number of variables scenario is just too big, you cannot use truth table anymore. Okay? So if the problem is very complex, you cannot use the truth table. If the problem is very simple, you can list down all the possible scenario, then you can use truth table. Okay? Or you reduce the problem size so that the number of variables is smaller. Then you know what is the action. Okay? So that is when you use truth table. Clear? So far, so good? So far, so good? Kaya and butter. What is this kaya butter? What is this kaya butter about? You go coffee shop, kopitiam and drink, is it? Breakfast. One kaya and butter. Okay, never mind. Okay, so especially guys, you must understand what and all must understand the difference. Okay, okay, must understand the difference. Okay, okay, or you shall regret. Hopefully, you shall not regret. Okay, where? Okay. So truth table formatting. Now we're going to talk about truth table formatting. So the truth table formatting, it will depends on the lecturer who set the exam question and so on. So you have A and B, you have 0, 0, 0, 1, 1, 0, 1, 1. Okay. So you're going to use like this 0, 1, 2, 3. Another student, they use this one. Start with B instead of A. Which one is correct? The left one or the right one? Which one is correct? The left one or the right one? Both is correct. But then marking will be a hell for a lecturer. Okay? The marking will be a hell for a lecturer, all right? Okay? Lecturer will be pening kepala. So you should standardize. MSB is A. So it will be A, B, C, D. A will be the MSB, not D, C, B, A. Some student, even better. What happened? Okay. Some student, what they do is like this. There's the truth table. Wow. How to grade lah, man? I tell you, like this. This 2 variable only. But what if you have 4 variable? How are you going to grade? So the only acceptable way is for you to use like this, like this form. Okay? Alright, don't simply use like this. I tell you is if 2, 3 students okay lah, 10 students still okay. But if 100 students, how are you going to mark? Alright, one student do like this, one student do like this. Wow, I tell you after you marking all the paper your eye will be only 0 and 1 only, nothing else. I can tell you that. Okay, so you should follow the standard. The standard should be like this lah, easy. Okay, follow this standard. This one, okay? Follow this one, then it will be fine. Everybody follow this one, then it will be fine, okay? Easy for everybody. Okay. If you do it, computer graded assessment, then you must fully follow the standard. If you do like this and if the computer grade like this and you do like this, then finish lah. Even though you do is correct, your computer will grade you wrong. Okay? All right? Okay, so there's a table, truth table formatting. So you can see 0, 0 will be 0, 0, 1 will be 1, 1, 0 will be 2, 3 will be 1, 1. Okay? And another thing about this course, you must really know how to do binary. You must really know how to do binary to hex decimal conversion, all right? Without calculator. Okay, you must know how to do that, okay? In your head, okay? In your head. Okay. Then you also have the not table. Not 0 is 1, not 1 is 0. So that is this A, not A is this one. Normally, they have a symbol for not A. Let's say insert symbol. Where can I find? Can I find the symbol? Let me find. It will take some time. Cannot find. Cannot find the symbol. Sorry, cannot find the symbol. Okay. The symbol will look like this. Like how I should. Okay. Next time I show you. Equation. Or you can find is like this. Not A. Not A will be like this. Not A, like this. Sometimes people do it like this. Okay. So if you have not N, you can also represent it with NAND. So this A and B, not A and B will be like this. Okay. So 0 become 1, 1 will become 0. Then you have no, you have 0, 0, 0 become 1. Okay. So this is no, not all. Okay. Okay, now we have this symbol labs, all right? So we stop sharing this one for a while. And we're going to share there. Okay, so just wait a second. Okay. Okay, sorry, the delivery man came. Okay, I have no control over when they come and all that. Sorry about that. Okay. All right. So it's standardized the answer. Okay, you can say you have to standardize the marking. Okay, standardize the Okay. Right. Standardize the formatting. Okay. That's that's the way to do it. Okay. Right. Okay. Just like let me ask you lah, if you apply for a job and you use your own format instead of the employer format, do you think they'll accept you? You think you think okay. No. All right, unless you accept you, unless you say no pay lah, no pay job accept lah. Okay, no pay job accept lah. Okay, you know when you apply for a job, they have plenty of choice, all right. Why should they choose someone who rebel? Okay, just like certain famous star, all right. You talk something negative, straight away he will ban you from your Instagram, from YouTube. He will block you from his channel. Famous star, okay. Famous star, okay, or famous celebrity or whatever lah. So if you talk something bad, sure no, kena ban one, sure kena block one immediately. Don't have to say. They got so many people say they are pretty. Why should they listen to those negative people? Okay, even though you might be right lah, all right, but it's not for me to judge. Okay, all right. Where are we? Okay, so we're going to go. Okay, can you see the lab? Okay, so you have the input. So these are the inputs. Okay, you have ground, and then you have power. Okay, input, out. Then here's button, or turn on and off, constant value, stepper. Then you have counter, and you also have a random input or output. Okay, then you also have output. This is the output, 0 or 1. You can have LED. You have hex display, 7-segment display, square. Okay, all this 16-segment display. Okay, then you have gates. All right, so these are the gates that you use. So let me go and take another output. Oh, cannot put another output, put here. Okay, and I put another output here. Okay, so I connect the wire. Connect the wire. So this is for this semester, we'll use this circuit waste simulator. Okay, so you can get it from this URL. Okay, so you can see the AND gates. Right, this is the AND gates. So 0, 0 will be 0, 0, 1 will be 0, 1, 1 will be 1, and 0, 1 will be 0. So the AND gate, if you put a NOT gate in front, this is a NOT gate, it will become a NAND gate. So you can see it's still 1. Is it 0, 0? It's still 1. If put 1, 1 is 1 here, and when you NOT it, it becomes 0. So these two gates are equivalent. This is the NAND gate. This is the AND plus a NOT gate. All right. So this is an OR gate. So 0, 0 is 0. When you put it in inverter, is 1. So you can see 0, 0 is 1. So basically, this NOR gate is actually this bubble you push all the way in front here. So this is a NOR gate. Okay. All right. So you put if it's 1, so this one will become 0. So both of these are equivalent. Okay. Equivalent circuit. Okay. Clear. So you'll be using this for your simulator. Okay. You can do plenty of things. You can do until tomorrow also can. All right. Plenty of problems to solve. Okay. Any question about the gates? So I only show you 2 input, but actually you can also get 3 inputs or 4 inputs. All right. There's no 3 input. There's no 3 input. Only 2 inputs only over here. All right. Gates. Then you have chips. Don't have chips. Miscellaneous. Okay. Circuit. Tools. Okay. All right. Any questions so far? No, huh?
So I have a question.
Okay, ask.
For the formatting the truth table, is it compulsory to draw the first column of the truth table?
You just follow the format as per I show you in the slide just now.
Yes, yes.
Like, just like okay, let me. Okay, so like this. Okay.
Yeah.
Okay.
My question is that compulsory to us to follow this?
You should follow lah. Should follow this one lah. Okay.
Is it necessary to draw the first column, which means the number 0, 1, 2, 3, instead of drawing A, B?
Oh, you mean this one?
Yeah, just yeah, the one.
This one is optional but it's better you draw also lah. It's just one line only lah. All right. So because sometime in the future, they will say it's like this. You want to put a function x a b c equals to 1 when it is 0, 3, 7. Okay. So this 0 means here. 3 means here. 1 means we have 4, 5, 6, and 7 is below lah. Okay, 7 means all 1 lah. Okay, clear. Okay, so sometimes they will. Okay, so this number is referring to the binary value of all the variables. Okay, sometimes we will say that f like this a b c equals to 1 when it is 0. So you have to design a circuit. Design this circuit. Okay, so that's the purpose of the number. Okay, stop sharing. Where's the circuit? Okay, so this is a circuit and or symbol. Okay, any questions? So you play around with this lah. Okay, they also have a XOR. XOR means neither or neither nor lah. Okay, so this is the circuit for the XOR. Okay, XOR circuit. Where can I have the chip? Okay, XOR circuit. Okay, now we have okay. So you have a XOR circuit. 0, 0 is 0, 1, 1 is 0. If either one of them is 1, this will be XOR. All right. XNOR will be the opposite of XOR. Okay. And then the next thing is, why do you have NAND gates and NOR gates? Why? Why? What's the reason? Why? Why? What's the reason? What is the reason? Anyone know? What's the reason? Hello? Are you all still there? Are you all still there? What's the reason? Hello? Am I this? Okay. So why use NAND? You need to crack your head. And you can think clearly in AND or why use NAND? But isn't it that it's better for you to use AND and NOT, isn't it? Very easy, isn't it? AND and NOT, very easy. Why you want to use NAND or NOT? You need to crack your head and think in De Morgan's way. Right? Why? Okay? No lah, not too complicated lah. Okay, let's say you have a chip, you have a function, right? Some function 1, you might use 3 and 2 or and 1 not. Then you have a function 2, you might use 10 and 1 not. Then you have function 3, you have used 10 or and 1 and, like that. How you going to optimize the circuit? 3 different components in your chip. So what you're going to do? So in your chip, you just have NOR gate, NAND gate only. Every function is expressed in NAND gate only. Okay. So in your S6 this NAND gates only. Here, only one type of gates, NAND gates only. So you can build as many as you want. Connect how you want to connect them, up to you. But just NAND gates only. Okay, so it's much easier. Not necessarily reduce the size of the circuit. It makes things easier. Okay, it makes things easier. Because you might have function 1. Function 1, you use 100 OR gates one AND gate. Then function 2, there are 100 AND gates, one NOT gate. How you going to optimize? Okay, so what you're going to do, you just design the chip to have all NAND gates. Okay, then what you're going to do, you express the function in terms of NAND. All right. Okay, clear. Okay, can you see the PowerPoint slide? Can you see the PowerPoint slide? Can you all see the PowerPoint slide? Can or cannot? Okay, got it. Okay. All right. So, so in math, it's proven that any Boolean expression, any truth table value, can be expressed in terms of NAND or NOR gate. All right. So you can express it. If proven mathematically, no more argument already. Okay. All right. So it's proven mathematically. So no more argument already. So therefore, you have NAND gates and all. So in real chip, you only use NAND and NOR gates only. Okay. All right. Understand? Okay. Then you have XOR. Okay. I think I already cover. So I hope you understand the basic concept. So I think I already cover more than enough for today. So anything else you want to ask? Play around with the simulator. Okay. Anything else you want to ask before we close shop? Anything? Calling 1, calling 2. Okay, attendance. Probably attendance. Attendance. Elijah Tan. Who is this? Okay. All right. Okay. Attendance. Okay, I think I stop recording now.